Well, hello everyone. In this video, I'm going to explain open statements. Okay. Now consider the statement x plus 3 is equal to 6. Tell me whether this is a proposition. Someone please reply me whether it is a proposition. Well, this is not a proposition because I cannot say x plus 3 is equal to 6 whether it is true or false because we do not know value of x. Okay, so when I put value of x as say x is equal to 3, then 3 plus 3 is equal to 6, I can say it as true. In that case it will be a proposition. But when we do not know whether it is true or false, then we cannot call it as proposition. So such statements are called as open statements. Okay, I am repeating here. So the statements which are involving variables are called as open statements. And here this variable x is called as free variable. Okay. Here I have written it is a free variable. X is called as free variable, and open statements are denoted by p of x, which are involved in this open statement theory. Well, now let us consider one example. P of x is x less than or equal to 3. This is one open statement. And one more is q of x is equal to x plus 1 is odd. So this entire thing is the second one. X plus 1 is odd. Then third open statement is r of x is equal to, or it says that x is greater than 0. Well, these are the three open statements. Now question will be like, write down the truth values for the following. See, there are three statements given, 1, 2, 3. So let us take first one and try to say whether it is true or false. Now p of 2, but what is actually p of x? Here x is less than or equal to 3. Here I will write first p of x. X is less than or equal to 3. Now x should be replaced by 2 because here he has given it as 2. So p of 2 will be, x should be replaced by 2 everywhere. So 2 less than or equal to 3. Now I can say that this p of 2 is true because 2 is less than or equal to 3. Fine. Well, similarly, second example. Let us take second one. Solution for second one. P of minus 1 and q of 1. Now first let me write p of x and q of x. What is p of x? X less than or equal to 3. And what is q of x? Here it is. X plus 1 is odd. Now value of x should be taken as minus 1 for p of x, and value of x should be taken as 1 for q of x. So here minus 1 is less than or equal to 3. This is one statement. This and as it is. Now x plus 1. In this case x will be 1. 1 plus 1 is odd. Now tell me, minus 1 is less than or equal to true. It is true or false? Yes, it is true. So I can write it as true. And 1 plus 1 is odd. It is false because 2 is odd. This statement is false. Now true and false is always false. You just remember the truth table for and. There we had like 1 1. So if I write p q, p and q will be 1 only in this case. In all remaining cases it will be 0. That is false. So in this case true and false is false. So I can say that the second example is false. Similarly, let us take third one. P of 0 conditional q of 0. P of 0 conditional q of 0. Now let me write p of x first. What is p of x? X less than or equal to 3. This is given. Conditional What is q of x? Q of x is again x plus 1 is odd. X plus 1 is odd. Okay. It will be like x less than or equal to 3 conditional x plus 1 is odd. Now in this case, x should be replaced by 0 in both cases, in case of p of x as well as in case of q of x. So 0 less than or equal to 3 conditional 0 plus 1, because x is again replaced by 0. 0 plus 1 is odd. If you consider this statement 0 less than or equal to 3, it will be true. Then conditional as it is. 0 plus 1, that is 1 is odd, it is also true.
True.
But for conditional, we have seen first input should be high or true, second input should be false, then output will be false. So in all remaining cases it will be 1. Now we should focus on this first case, 1 conditional 0, whether we have that is true conditional false should be there. No, if no, then it must be true. So we can conclude that the given third example is true. I hope you have understood this.
Yes, sir.
Yes, sir.
Now we'll discuss about quantifiers. Now let us consider these statements. All squares are rectangle. For every integer x, x square is non-negative integer. Third one, some determinants are equal to 0. Fourth one, there exists a real number whose square is equal to itself. These are the 4 statements. Okay, I hope everybody is listening. Now in these 4 statements, we find some words like such as say all. So in this statement, this all is important. I'll tell you why. Now in the next statement, if you consider this for every, this is important. Now some, okay. Now there exists. Now these words will define the statement. Okay. When I say all squares are rectangle, it has meaning. Means if it is a square, it must be rectangle. Okay. For every integer x, means you consider any value of x, that is for every x square is non-negative integer. Now here some determinants are equal to 0. It means that not all determinants are equal to 0. Few determinants are equal to 0. Now fourth, there exists a real number whose square is equal to itself. Now again third, there exists means there must be a real number whose square is equal to itself. But not every real number whose square is equal to itself. So I hope you are trying to understand it. Okay. Now few notations. See this notation, it indicates there exists. It means that there exists. And one more, this, it is indicated by for all. I think you have come across all these notations in previous years. So there exists means it is called as existential quantifier. Okay, and for all means it is universal quantifier. So you try to remember these two, I can say words, existential quantifier and universal quantifier. Existential is denoted by this there exists, and universal quantifier is denoted by this for all or for every. Not only for all, here I can write for every or for any. Such words are denoted by this for all. And there exist, instead of there exist we may write some, or sometimes few people, like that. So such words should be denoted by this there exists symbol. Let us consider one example now.